Welcome to the Professor's Du Bois channel. I am Professor Victoria and this is Professor Corey, and today we're going to be talking about the types of chemical reactions that you might encounter in general chemistry.
Okay, so we've got several types of reactions here, and we've talked about chemical reactions before where reactants will form products. And so what we've found is that there are several different types of ways that this can happen. And if we look at our first example up at the top, this is a common type of reaction where we have two elements that will combine and form a compound. And there's a name for this. It's called a combination reaction. Sometimes they call it a synthesis reaction, but combination or synthesis. And I like combination because it's kind of like combining. So it makes me think, oh, I combined two elements and I made a compound. Now, one tip or one clue you can look for with a combination reaction is the number of things on the reactant side is greater than the number of things on the product side. And that's really oversimplified. But you can see we've got two elements on the reactant side, and on the product side we have one compound. The second example below is almost like the opposite, and this has a name. It's called a decomposition reaction, and you can think of it as decomposing. It's
breaking down.
Yeah, and that's exactly what's going on. So we have a compound that's breaking down into its elements in this case. This A and B, these are not real elements. This is just to help you kind of visualize what's going on. We'll look at some actual reactions soon. Yeah. So like the combination, the decomposition, we have more products than we do reactants. So why don't you talk about the displacement reactions?
Okay, I did want to mention that it doesn't have to be just two elements combining to be a synthesis. You can have a compound combining with an element or two compounds combining to a new compound. Just didn't want you to think that that was just two elements combining.
That's a good point.
We have a couple other examples here, and we have a single replacement or a single displacement. Replacement and displacement you can use interchangeably. And the single is here on this third example, and the double is down here. And what the difference is in the single replacement, we do have an element with a compound, and the element will replace or displace one of those other elements. And then it is in combination in a compound, and it has displaced the one, and now it kind of kicked it out and made it an element. The double displacement or the double replacement is where the two combine, the two break apart and then they switch. So they switch partners. So we have the C is over here now combined with the A. Oops. So A is combined with the D here, and C is combined with the B.
But the C could have went with the A and the B with the D. That would have also been a double displacement. Right.
Depending on the positives and the negatives. So we always have to have a positive ion combined with a negative ion, and that's
right. That's a good point.
There.
So if we go back to that single displacement or single replacement, if C was a metal, then it would replace the metal in the compound, and that's important. So
we'll show you some examples, some real examples as well. So broad types of reactions: synthesis, decomposition, single replacement, double replacement. So let's look at some.
And that synthesis can be called a combination, as
right.
we see here. So again, this is just saying the number of reactants greater than the number of products. We have an example using A and B, but let's look down below. So these aren't elements. We've got water and SO3 forming H2SO4. So this is a combination reaction, and it's not elements. It's two compounds combining to form a compound. So again, it follows that rule that there's more reactants than products. And then the third example there with the nitrogen and the hydrogen forming ammonia, that's also a combination reaction.
Yeah, with two elements making a compound. Decomposition, like Professor Corey mentioned, the number of products is greater than the number of reactants because we broke down the reactants into more than one. In this case, we had one thing breaking into two, one thing breaking into two. It's not always that, but it is something is being broken down into different substances. So that would be decomposition.
And we have our displacement reactions, and we can use the term replacement in place of displacement. And here, the products and the reactants, they're equal. And there's two categories. They can be either the single type or the double type. So the single type, we've got in this example A, so we've got an element and we've got a compound BC. Now notice here that the A displaced or replaced the B. A is now with C and B is a single. So with these single displacements, we always have a single on both sides of the equation. So looking at an actual example, down below we've got aluminum reacting with HCl, hydrochloric acid, and so the aluminum combined with the chlorine to make aluminum chloride, and the hydrogen was displaced.
Nice little graphic here where you can think of this as a person cutting into a couple dancing, and the A in this case is replacing the B in this, and now A is dancing with C. So this kind of represents this reaction up here.
And B looks really sad.
B's sad. Yeah, go take a seat, B. Sorry. Double replacement. You can also picture dancers, and you have two couples and then they switch partners. So take a look at this. So we have a couple different types of double replacement reactions: precipitation, acid-base, and gas forming. Precipitation forms an insoluble solid. So from a solution or two solutions being mixed together and forming a solid. In the first example here, we have lead nitrate combining with potassium sulfate when they change partners. Now, the positive ion has to go with the negative ion. So the lead can combine with the sulfate and make lead sulfate. And in this case, it is our precipitate because it's our solid.
And the AQ just means aqueous or dissolved in water.
Correct. Acid-base or neutralization reaction. That's an acid reacting with a base, usually forming water. Not always, but usually. And we're going to get into each of these separately in subsequent lectures. So this is just the broad view of the different types, and then we'll get into each one in turn. So we have an acid combining with a base, forming water. There's a little L here. And then our aqueous salt as well. So this is a double replacement. H goes with the OH. The Na is going with the Cl. When we write our salt, that Na is written first because the metal always goes first when we write formulas. And they combine in a 1-to-1 ratio. So that's an acid-base or neutralization. And the last one is a gas-forming reaction. So this is forming a solid, forming a liquid, water, and then forming a gas. And there's some different gases to look for. You may not know that they're gases yet, but hydrogen gas, hydrogen sulfide, carbon dioxide, oxygen, we've got SO2, NH3. These are all gases.
And they're the common ones. That's what you're probably going to most likely see.
That's what you're going to encounter for sure.
So this is just kind of an interesting aside, and we're going to come back to this later, but if we have these compounds, we've got the NH4 OH, that's ammonium hydroxide, H2CO3 or H2SO3. These three compounds, we have to make special note of these. These decompose. So we talked about decomposition reactions. So we could have a double displacement that forms one of these. Well, these decompose. So it's almost like two reactions going on. So if we produced NH4OH, that would decompose to NH3, which is a gas, and water. So it's this would be a gas forming reaction, and in this instance, even though we did produce water, this is not an acid base reaction. So you'll have to be good at looking for those acids and bases for the produce water to work.
It might be an acid base reaction that led to it. It might be both. Sometimes you have a combination of these things. So it might be an acid-base reaction that formed the NH4OH and then it decomposes. And so it's an acid base and a decomposition and a gas forming. So we can have several for the same reaction.
But take note of these three compounds, because when we write them as products, it would not be correct to write the product as NH4OH. Rather, we would have to write that product as NH3 plus H2O.
All right, so let's practice. So we want to know what type of reaction, and again, there might be more than one, so come up with as many as you can for these examples here. So pause the video and give it a shot. Here are your answers. And notice how sometimes, like this first one, we have decomposition and gas forming. Several times you'll see that there's more than one type of reaction that you can classify it as.
One thing worth mentioning is that in the laboratory, these gas-forming reactions are very powerful because we can visually see bubbles. And it's an observation in the laboratory that you know that there's a reaction going on and that it's forming a gas just by the presence of bubbles.
Yeah,
so
it is neat.
That's
fun.
Something to put in your observations in your lab if you're working with gas-forming reactions.
Right. And oftentimes you can see those precipitation reactions as well, and you can see
sure.
the solid form. The liquid water, not so much.
Right.
Thanks for watching. We appreciate you tuning in. This is the place to learn chemistry where you matter.